I almost forgot to start making the movie. So what we did, hey, try to get this equation, both in sine and cosine. Stop the movie and do it. Okay, there's the answers. Good job. All right, now we're going to Navy Pier. What? Field trip? Stop missing school. All right, all right. Okay, now, so if you read the question, the diameter is. Let me get my fat head up here. You know what? Just delete me. You're gone. All right. Okay, so I just up my face. I gotta start losing weight. All right. So what is this number from there to there? What is that number? That is 186. That's from the reading. Okay, and then it says if you look at the reading that the top point is 196 at your highest point. So everybody, what is this from here to here to the ground? What is that answer? 10. Very simple. So we have 10 feet here. So just pictorializing the situation, that's what we have. And that actually makes sense. I know how it worked in the old one. You actually went up a ramp to a platform. So they're probably talking about, you're 10 feet above the ground. The platform might be about 9 feet above. And then it's like an extra foot that the chair is above that you walk in. You do have to like step up 1 foot to step into the chariot. Kind of like a chariot. My whole family fit in the carriage. Well, now I think about it, I've been on that thing twice. I remember going with my in-laws. Nobody cares. Anyway, so identify the maximum height. I didn't say that. Yeah, it said that. That's silly. And then what's the minimum height of the rider? What was the minimum height? We just put that down. 10. So we're getting on there 10 feet above ground, with that platform. Okay, so where do you start the ride? Do you fly in like Superman or woman? You got to take care of everything. But at the top of it or the bottom of it? When do you get in the chariot? When? Top or bottom? Bottom. So where does this start? Letter A, B, C, D, or E? You actually have two possibilities. What letter? Say it out loud. 3, 2, 1, go. A or E? I hope you said it. I hope I didn't hear B. Otherwise, you're climbing on the thing and then jumping in. Anyway, so I missed the ride, or you're too fat. You can't fit in this. My face. So too heavy. You have to wait for the next cycle, and then I have to wait for the next cycle. Sorry. All right, but anyway, so here's the start of the ride. Okay, so here's what we're gonna do. We're gonna make points out of this. What's the time, and what's the height? What's the time, everyone? 3, 2, 1, go. If I don't get group responses, this is coming back. Wait, who's student number 11? Did you ever go? Did you? What did you say? Oh, you did the cosine. All right. Good. All right. And then 0, comma. What's the next part? 3, 2, 1, go. 10. All right. And then you know where we go? We go up to the high point, and then we go down to the low point. We're going to go to this point. What is that coordinate, everybody? What's the time? 3, 2, 1, go. Oh, no, I didn't hear it. Don't make me do it. 5, comma, what? 10. All right, now, what's this point? If you get your calculator out, I'm going to hit my head up against a wall. What time should that happen at, everybody? 3, 2, 1, go. 2.5. And then what's that height, which I did mark up there? 3, 2, 1, go. 196. This makes it so easy. This is why I'm like dumbfounded how many people are just like, I don't get any of this. What? Okay, come on. All right, now what's this one? Don't get the calculator out. What is that number for time? 3, 2, 1, go. 1.25. And then now we might need the calculator for this a little bit. What do I do with 196 and 10? Do I add or subtract? It is add. If you subtracted, you better do the next thing. And actually better do the next thing still. It is add, though. So it is 206 divided by 2, which is 103. But you better do this. You better check, is this equal to this? That was a bad attempt at a brace. These two should be equal. So 103 should be the same distance to 106 as it is to 10. And how far is that distance? What is that number? It's 93. It's easier to go 103 to 10. That's when you subtract. And is this 93 and is this 93? And the answer is yes. So yes, I add and then divide by 2. Right? So we gotta be more not robots. What's the formula? Do I add or subtract? No, what's the situation? You got a midline, so it should be the same distance up and down. So I discount double check myself. And then what's this one? What's 1.25 plus 2.5? 3.75. And then this is 103 again. So from this information, I should be able to get an equation. All right. All right. So here we go. Let's start filling in parts. By the way, what kind of curve do I have? I don't know why that just grabbed there. What kind of curve do I have when it's this? Is it upside down or right side up? Is it cosine or sine? Tell me that right now. Upside down or right side up? 3, 2, 1, go. Upside down, sine or cosine? 3, 2, 1, go. Cosine. If you don't know that, you're severely and totally. Say it to them. Behind. We're tired of this. We're tired. When we're in groups, you got to carry your weights. You got to do something, not nothing. By the way, do I have a phase shift? Do I have a right left shift? Do I have a right left shift? Yes or no? 3, 2, 1, go. No. Okay, we should know that. So I'm going to tighten this up a little bit. I don't even have to worry about a phase shift. I do need a number there, and it closes. Nice. We know what's up, so we're going to fill in that blank. Now, I did put the negative in there. All right. What's the A value? The number is on our chart over there, or our picture. What's the A value? 3, 2, 1, go. 93. It's the same distance up and down from the midline. Let's go to the last blank. What's the last blank, by the way? The number is in the coordinates. 3, 2, 1, go. 103. If we don't know this, you're behind. All right. We've been graphing shifted graphs, I think since last week. I think that's when we did the shifted up, down, right, left ones, both Thursday and Friday. And now what's the period? First of all, what is the period? What number? What is the number for the period? 3, 2, 1, go. You're waiting for 3, 2, 1, go, I hope. And then switch. When you switch B and 5, you get 2 pi over 5 for B. Let me turn that into a fraction. My blank's in the way there. And there is your equation. All right, go to your calculator real quick. And actually, I keep making this change. I know we're halfway through, but I want to make these points and make an idea happen here. So what this is when will you be, how far above the ground is the rider after 1 minute? That's F of 1. So that's what we're going to go to the calculator with. So it is 2 pi over 5 times 1. I will put that in parentheses, and then plus 103. So what we could do, because there are, actually I guess there aren't, but we will do that. Y equals, so far going so good. Was that the equation? No, weird. So I will clear. Make sure you are in mode. Where am I at? Old man. Technology. Make sure you're in radians, otherwise your graph will be a disaster. 1 radian is not the same as 1 degree. All right, so putting it in degrees gives you a completely weird graph. We haven't talked enough about degrees. That makes me sad. Wish we did do some more degrees, but whatever. Can't always get what you want. All right, I'm going to type this way. He goes too fast. Wrong. Cosine. And then you can just do 2 pi. Oops, that's E. Let me go back. 2, let's watch this guy struggle typing buttons. Pi divided by 5. Do I really have to take times 1? Oh, actually, wrong. I do need X, because I'm going to show you how you can do this. Plus 103. I think I just forced my other class to do this. I need that X because I want to get the graph. By the way, what should the window be? Well, I went from 10 to 193, and it happened in 5 seconds. So maybe I'll go 10 seconds. I'll see 2 cycles of this. This is the kind of stuff you got to know, right? And then our minimum. 0 to 60 is not enough. That's for a later question. I think it went up to 196. So I want to go to 200. Boom. Okay. Now that I have that, that's exactly what I saw here. 0 to 5. 5 to 10 seconds. Should make sense. Second, calculate. I hope you're doing your own stuff. And then we can calculate a value of 1. Enter. And by the way, I should have known that it would have been somewhere around under 100, because on the graph, you're right about here. Here's 1.25 seconds, so you're right about here in the rotation. Okay, so you should have made sense that it was under 100, a 3 at least, under 103. How long will it take the rider to reach the highest point on its first rotation? We already know that, 2.5 seconds. Okay, and then I like this one. Between the two times corresponding to B and C, are we increasing at an increasing rate or increasing at a decreasing rate? Which one is it? 3, 2, 1, go. Increasing at a decreasing rate. Why? We got a hand up. What's the hand? What's up? Oh, minutes. Sorry. You know what I was thinking about? It was our next question. Sorry. Gotcha. So why is this that? Because it's increasing, but it's concave down. This goes all the way back to 1-1, our very first thing that we ever did. All right. All right. Let's go to the next one. There's that second bell of the half here. This will go faster now, but not really. I got to get in your head about how to make this easy. You might want to make some drawings. Okay. So watch me. You have to emulate this. Might have a question like this on the test. Student rides with his bicycle to school each day. Good for him. All right. Pedals are mounted on a bracket whose center is 29 centimeters from the ground. If anyone knows how a bicycle works, you got this little circle here that drives the chain. All right. And then here's where your pedals are. When I read later, the pedals start horizontal. So I'm just trying to draw pedals. Pedals aren't little dots, but that's where you put your feet. Then you go like this. I know I deleted my fat face, but I'm doing the motion of doing a bicycle, right? Isn't this how you pedal? Okay. So they're starting at a horizontal position. So this is 29 centimeters from the ground. So that whole distance is 29 centimeters. Right? Just making sense out of the picture, making sense out of the situation. Next thing, each pedal is 16.5 centimeters from the center. So this is 16.5 centimeters. Now, the way this works, we usually pedal this way, right? You go like this and then they go forward, okay? So again, doing my arms like I'm pedaling with my arms. By the way, there is a good machine in the fitness center that they do have that. Anyone see that in the fitness center? Put your two hands in here, you go like this. It's an arm workout. Anyone ever see that one? It's actually a really good workout. Good for the shoulders, and nobody cares, Mr. Samuelis. Okay, so you know what pedal I'm going to pick? I'm going to pick this one. You know why? Because this pedal rises or falls first. What's the answer to that? Rises. So what I'm trying to create is a positive what? What do you think? Is this going to be a positive sine or a positive cosine? What do you think this is going to be when we graph it? The answer was sine. Here's why. We're going to try to graph this out right now just from this information. We are starting at the horizontal position, so we're starting at the midline. This is why we should have guessed sine. What is this midline? What is this number right here? How high a ground is the pedal right now? 3, 2, 1, go. Everyone should say 29. If you're not saying that, you're a bum, or you're severely and totally behind again, and you need to pick yourself up. Now, this is why I picked the back pedal. I wanted to get a riser first. The front pedal starts down. So then what's this next? Not the X value. We'll get that in a minute. What's this value? What's the high point? What do we got to do with these two numbers, everybody? 3, 2, 1, go. Add them. And what does that end up becoming? I believe 45.5. Is that right? Someone check me on that. Right? So it gets to the high point. Then it gets back to the middle at X amount of time. We'll get that in a minute. Then it gets to the low point. What's the low point? What do I do with these two numbers, everybody? Subtract. 29 minus 16.5. Check me out. Is that 12.5? Is that right? 12.5? Get nothing from third hour. Is that 12.5? Okay. That's the low point, and then back to the beginning. I know you maybe couldn't care less about the bicycle and the pedal positions, but in circular motion questions, heck, our orbits are almost circular. They most definitely use trigonometry to figure out where Mars is when we're sending probes to it. You know, there's a lot more going on, but trigonometry is in the details. All right, now what's this x coordinate? What is that x coordinate? 3, 2, 1, go. Everyone should know. Oh, no, I'm wrong. All right, so 12 cycles per minute. I hope I woke you up with that yelling in the video. I'm going to change minute to what? So I can break this down. Oh, break it down. 60 seconds. So 20. Anyone know what that song is, by the way? Oh, break it down. Nobody? Can't touch this. Oh. Anyone know that song? Thanks. Okay. How many seconds is it one cycle? Simple reduction of fractions. What would the answer be? 5. And then you know what's stupid? I wish we'd have made this a little different. It's the exact same numbers from the last question. That's why I made that little mistake that you caught me on. I labeled seconds because I was thinking about this one. And then for movie purposes, if you don't have this at this point, I don't know what to tell you. So what is this a picture of again? What is this a picture of? Sine or cosine? Sine. So it's going to be sine, and then it's going to be positive. So I'm filling out these blanks. Notice I don't have a phase shift again. So I just have a number for the period. And then it is plus because we're up. Okay, what's that first number? Let's see how many people answer. What's that first number in front? 3, 2, 1, go. 16.5. It's actually the distance. It's not 29. 29 is the midline. Okay, so what's the last number? I think I just heard the number. 3, 2, 1, go. Anyone not saying that number? Yeah, you're a dud. All right. And then, okay, what's the period? Well, the period's 2 pi over b, and the period is 5 seconds. That's why I made that mistake. Switch them up, and you get 2 pi over 5. So that's why that was my mistake. This was in seconds, and I was thinking about this one. Okay, I'm not going to bore you with this one. You just input 23. I'm going to bore you with this one. When is the puddle 40 centimeters? That means y is 40. We want to know the when, which is x. So now we're going to go to the calculator, and this will finish this question off. 2 pi over 5x plus 29. And then I'm going to go ahead and open up the calculator. I think I'm going to do it on the board here. So I do want to see this. I don't know why that came up. Y equals. By the way, if you have, maybe I'll just slide this over. If you have a graph error, make sure this happened to someone first hour. Make sure your plots are off. Turn that plot off. That better not be black. All right, we don't want those showing up, because the problem is when you have your plots on, then your graph may not graph if you don't have any points in L1 and L2. So here's what I'm going to type. Clear 16.5. Boom, boom, boom. 16.5. Sine. And then I can just do this. 2 second pi divided by 5. Don't be a goofball in first hour and forget x. All right, a couple goofballs did that. And then I forgot, what was that? Plus 29, I see it there, plus 29. And then you want to go y2 equals 40. Now, honestly, my window is ready because it says, oh no, in the third cycle, 5, 10, 15 seconds is the third cycle. Okay, so I do want to get that, right? I didn't do that first hour. I think I got distracted by someone saying, I didn't get this, I got something wrong. And right, and then this is 70 or something, I don't know. I just want to be above the high point, which would be 44. Probably should have just done 50. It's no big deal. Graph. All right, So that's definitely what you should get. And then what do I want to get? The into anyone? Intersection. But it's in the third time, the third cycle. So second, calculate. Now I'll slide my desk over and actually make this larger. So now I want to calculate the intersection of these two graphs. Ooh, I'm right around the second cycle. 1 cycle, 2 cycles, 3. So I want to be there, and then the answer would be this. And then the next one, we don't even have to do calculator work. It's just analyzing the equation. So this video will end pretty fast. Remember, 1, 2, 3. You hit enter 3 times to finally get that intersection. So when will it be? It will be about 10.6 seconds. And then if we want to do the other one, I'd have to see how that's worded if I need both of those. Yeah, I guess in the third cycle, I would be at that 40 inches height 2 different times, 10.6 and 11.8 seconds, all right? Because it is, doing that circular motion. All right, so circular motion, definitely sine and cosine. All right. Here's our last one. This is that we love this. This will definitely be on the test in some way, shape, or form. An analysis of an equation. Average monthly temperature, degrees in Fahrenheit. Town in central Indiana, probably similar to ours. January we're at our lowest. About July we're at our highest. December we're approaching our lowest again. Blah 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 blah. So how would I do T2? I'm not going to bore you with that. You just plug it in and solve, right? You just do it. All right. You can do that on your calculator. You don't need me for that. You shouldn't. What is the period of this function? What is the period of a temperature function? What should it be for any town? How many months are in a year? 12. But really, it does come from 2 pi over b does equal pi over 6. And then switch them. B equals 2 pi over pi over 6. And guess what 2 pi over 6 is? It's 2 pi times 6 over pi, which is that 12 that we thought we should get. All right, so it does work out. What is now? I don't need my calculator for this. It's a number in the equation. What is the average temperature, wait for 3 seconds, over a year? What is the average? It's a number in the equation. Which one is it? 3, 2, 1, go. 61.2, good. So I don't have to do that group thing. It's been pretty bad in here. Nobody answers anything when we're in our groups, and I just don't think you're really engaged because I see the results, all right? And they are driving me crazy. All right, and then which one's true out of this? Well, they're asking about maximums and minimums, maximum temperatures and minimum temperatures. We have a baseline, and then we go up, and then we go what? Down. And how far do we go up? We go up. What number? What number in the equation gets me to my maximum temperature? 25.2 or 7. Sorry, 25. You said 7. I said 2. And then we go below this by 25.7. So which one's true? Which one is the most true thing? A, B, C, or D? A, B, C, or D? 3, 2, 1. Anyone? Oh. 3, not B. 2, 1. C. Because this is the minimum temperature, and that actually hits it spot on. All right? That's the only one that's actually true there. These other ones are a little cryptic. They would have had to turn them in. I would have checked these first. Since this is true, that's got to be the true one. All right? The other one's not so much. All right. Stop sharing. I don't think that's too bad.